Okay, so we'll be covering expressions, calculations. I'm seeing a lot of my scripting students in here from earlier in the week. So we will typically go from real simple stuff to hopefully I'll show you a few tricks and things that you haven't seen before. A lot of this stuff is not just going to be typed out calculations on the screen. So slideshow is a VTScada application. So when I go through the slides, the result of the calculations are drawn on the screen as a widget. So just like you would configure your VTScada pages, all of these are pages, and my calculation results are just drawn there. So when I do these interactive demos, I'll open up the tag browser. We may change our calculations to demonstrate something. You'll see that change being made on the screen itself. Just like widgets, so if we start, when I show you some of the examples that we have to use calculations and widgets, those widgets are drawn on the screen, so it'll be a dynamic change. So you don't have to just believe me in PowerPoint that this stuff is working. Hopefully it works. So I'll get started. So introduction to calculations, basic example here. So an expression can be as simple as adding two values together. It's usually the simplest thing that we would show someone as an example of how to build an expression. So the normal order of operations are observed. So if you have, a multiplication is going to occur before a plus would occur or a negative would occur. So your normal, and then your parentheses also take precedence. So normal order of operations are observed in VTScada calculations. So here's a typical example of an expression. We'll see what these square brackets mean. If any of you have written any calculations, I'm sure you'll know what they mean already, but essentially this is dividing the values of two tags. So we're dividing the tank level by the tank height and multiplying by 100. Not sure what that calculation meant, but it's a good example. It would work. The steady state calculations, and I don't want to, scary word if we haven't done any scripting yet, but for the most part, we're going to be using what we call steady state function calls and calculations, and I'll show you the other side of those as we get along in the slides. Not used as much. But what the steady state calculations, in terms of an expression, you can think of those as they're always running, so they're always being observed by the engine. When they start, so if you have a calculation tag with an expression in it, when the calculation tag starts, that expression is evaluated, but it's not evaluated continuously. The engine is smart enough in that it'll evaluate the expression, and it won't evaluate it again until part of the expression changes. So the engine says, oh, something's changed, the value is going to change, therefore I'll immediately reevaluate that expression. Okay, so that results in the product being quite efficient because we're not just looping through and calculating this thing as fast as we can. Calculate it once, and then we watch for anything to change, and if something changes, we trigger a recalculation of that expression. Here's a few examples of how you would use an expression. Most commonly, I shouldn't say most commonly, but if you're using it inside of tags, the most common use is to set the value of a calculation tag. So if you haven't seen a calculation tag, we have this special tag type. And I'm going to bring up the properties. I just happen to have one here. And this is the tag that's displaying the value on the screen right now. So in a calculation tag, it's very similar to an analog status or digital status in that you can log it. You can draw it using all of our widgets. Its value will display on the screen. You can base alarms off it. You can use it as a basis of calculations for other tags. But instead of reading the value from a field device, on our Calc tab, there's a spot here where you can build a calculation. So this is a simple one that I use. It changes a lot, so it's good to use as a demo because every second it updates. This now function is a VTScada function. We'll talk about what they are and what they can do, but if you're ever interested in seeing what it does, or what a function like this is doing, all of them, they are all documented in our help file. So if I open up the help file and go to this now, I can click on it, and every time, the guys from the scripting class will have seen this, but all of these functions, which are, this is what we base our scripting around. We use these things to write our code, write custom tag types, but you can also use them in your calculations and expressions as well. So when you open up in the help file, it'll tell you how to use it. It'll give a good explanation of it, hopefully. And for the most part, there's a few times I've seen instances where it doesn't really exist, but usually we give you an example of code on how to use it, so you can actually see a real-world example of how that function is used in real code. Okay, but having known it, specifically the now function is a simple function that returns the number of seconds since midnight. And the 1 here is your interval in seconds, so it's going to update every 1 second. And you'll see that every second it updates this number, which is the number of seconds since midnight. If I was to change this 1 to a, not something too high, but I can change it to 5 seconds, you'll see this number won't update quite as frequently. And it should update every 5 seconds. Okay, so that's a real common use. We can also use a calculation and expression to control a tag parameter. So this just happens to be an alarm that I have. And if you look at the action tab of the alarm, so if you've configured VTScada, you know that you can disable an alarm. And what I've done here is rather than disable it to say yes, it's disabled or no, it's not, I've used an expression to determine if the value is disabled or not, if the alarm, sorry, is disabled or not. So I'm using this same now function. Every second I get the number of seconds since midnight, and I just happen to know that noon is 43,200 seconds past midnight. So what I'm saying here is any time past noon, this alarm is going to be disabled. Okay, so you can use these expressions to as parameters of your other tags. Okay, so we've seen it with tags. The third case, it's not the only one, but these are the most common things. You can also use it to control widget parameters. So this is a basic widget that I've drawn on the screen. I think it's just a rectangle. I'm going to open up the Idea Studio to see what the page is doing. And if I bring up the property of that, you'll see that in fact this is just a rectangle, so inside the shapes, I've just drawn a rectangle on the screen. But what I've done is under the color parameter, so instead of selecting a steady state color, blue, green, whatnot, I used an expression to set the fill color. And by now, you'll be accustomed to seeing this now function. It's just number of seconds since midnight. And instead of dividing by 2, I'm getting the remainder of a 2 division. And I'm saying if that's equal to 0, I'm going to set the value to 10. If it's not equal to 0, I'm going to set the value to 20. So if the number of seconds since midnight is an odd number, I'm going to get one color. If it's even, I'll get the other color. So I'm just shifting between green and orange, green and purple every second. Okay, so again, all these things are things you can do through the GUI, not having to open up or use an editor and write script code per se. So a real important factor when you're writing expressions is a lot of times what you want to do is reference another tag. You're not looking to add 2 constant numbers together. You're looking at maybe you're looking at a tank. Maybe you're bringing it in as % full and you want to convert that to feet. Maybe you have feet and you want to convert that to volume if it's a nice cylindrical tank. So you're looking at using the value of a tag inside your expression to modify that, maybe to add it to another tag and return that value to either use as an alarm, as a value of another tag to display on your screen or whatnot. So just for historical sake, and because you may see it from time to time, if you set an expression up using a widget, it's a little simpler than writing it with a tag. We don't have an expression editor in our tags. You have to know how to write these expressions somewhat to build them. But In our widget, in our Idea Studio, when you build a widget and use an expression to set the parameter of a widget, sometimes you get these nice drop lists and trees and there's parameters and you can expand and actually pick the things you want. When you do that, if you happen to look at the code a different way, or if you open up the page source code, you're not going to see a nice pretty interface. You're going to see our historical method of accessing tags. So that's why I want to show you this. So if you do see that, you know what's happening there. Okay? So to rephrase, the GUI tools are actually writing code for you. And if you ever happen to look at that code, I want you to understand what it means and what's happening. So it looks quite complex, but it's going to be the same pattern over and over again. It's not that difficult to understand if someone tells you. So in order to get the value of a tag historically, you had to use this scope function. It's outside the scope, funny enough, of this presentation. But just trust me that it's what you have to do. So a scope function lets you get a tag value. So what you have to do is you always reference, not always, but in most terms of what we would do in these calculations, you would use \VTSDB as the first parameter of scope, and your second parameter of scope would be a text string of the tag name. So in this case, I'm looking for a tag whose name is tank1level. Okay, so this gets me a reference into the tag, the first portion of it. And now you see the second portion there, we have a backslash. And oddly enough, that's called our scope operator. But when you have what we call an object value, so you have a reference into not the tag's value, not its name, it's a reference to the tag itself. And the tag itself is a module full of variables, parameters, and whatnot. So the scope operator says once you have a reference to that object, you can use that backslash and access any of the variables or parameters within the tag. Okay, so down the next slide it takes this and it makes it really easy. So scope VTSDB tank1level, that will return the object value of the tag. And if I use a backslash value, it returns the value of the tag that I just referenced. Okay? So I like to think of that backslash that you step into the module and reference any value within it. So if I wanted to get the same tag, if I wanted to pull back its description, I can use a backslash description there. And I can access the description from the same tag. And now here's the new way of doing things since, I don't know, 3 or 4 years ago, I'm not exactly sure. So now you can use these square brackets. And they're just shorthand to the engine. So if you use the square brackets and add an expression, the engine knows how to interpret that. In the background, it's actually doing this scope VTSDB for you. But it just lets you type it out a lot simpler. So if you just use the square brackets with the tag name within the brackets, the system will default to returning the value of the tag. Okay, so if I had my tank1level here, no backslash anything, it defaults to returning the value, which is currently 3. So if I want to refer to anything other than the value, just like we saw in the earlier slide, you can also use the square brackets instead of the scope VTSDB to obtain your tag object value. But you can now use the backslash name, backslash description, which would return the same that variable that you're actually intending to look for. And one final point here is the expression is going to reference its nearest sibling. So I'm going to show you a little bit of what I'm talking about here. So you'll see that I'm just trying to demonstrate how this would work, but I have 3 tags with essentially the same short name. So I have tank1level, and a child of that is tank1level. The child of that is tank1level. And each one of those tank1levels has a different value. So when you use these square brackets to refer to a tag, the scope, meaning the location in your tag hierarchy where you use that square bracket, it's going to refer to the to the tag that's its closest sibling. So this square bracket tank 1 level happens to be used in this tag, which is a calculation tag. Okay, and it shows me the value, but the actual expression is just tank 1 level. And if we look at the tag hierarchy, it lives right here, value. It's using this tank 1 level because that's the closest one, the closest sibling that it has. Okay, so, but I do have 3 tags at the same name, having a value of 1, 2, and 3. So if I was to disable tank 1 level here, I see that the value now changes to 2. So it doesn't have 1 at this level to refer to, so it works its way up the tree to find the next tank 1 level. And that's the next sibling in line. Okay, and this tag here is doing the same exact thing. So it's finding its first sibling and drawing the name. So if you look at the name here, it's all this special stuff I have for my slides, but we get the tank 1 level, tank 1 level. So if I was to re-enable the one that I disabled, I expect this value to switch back to 3, and the value of name should increase to, say, another tank 1 level because I'm going to start referencing my closest sibling again. So a disabled tag is not running, so if you disable it, it's ignored. It's still in your database, but it's not in memory, it's not used in calculations. Okay, so it goes back to referring to the tag that's closest to it. And here's some examples of some referencing that I talked about earlier. So we've seen the backslash name, backslash value. A real important one is short name. Sometimes you're trying to draw a page and you may want to concat a string up to have a description or some type text on the screen. You may want to use the name of the tag. So as we see back in my previous slide, name for that tag is this full long thing. Every tag in VTScada will also have a short name variable. And if you refer to the short name, you're just going to get the last portion, so the actual name for that. It's not the actual name, it's the last portion of that tag. Okay, so this one's just giving you tank 1 level. So I have a lot of people that ask, so how do I know what's available, what I can get to? There's 2 ways of doing that. Anyone who's taken the scripting course will be a little bit more comfortable with the source debugger. But even if you haven't, I'll show you how to get to those parameters to see what's available to you. So if you haven't run it before, when you install VTScada, if you select install the diagnostic tools or the debug tools, I think it's called, it will install the source debugger for you. So you can run that up. And when it starts, the system or the source debugger will present you with a list of applications that are running, and you want to select the application that you're working with. So mine's named expression and calculations. As soon as I click on that, I'll get a long tree of all the available variables and not variables, but modules inside my application. Now, by default, this tree is going to be a little awkward to work with because they're loaded in the order that the modules are loaded in VTScada. So it's going to be really tough to find certain things. But there is a button up here that allows you to sort the tree alphabetically. So I've never used a debugger with the tree not sorted. It's always sorted for me. It should maybe be the default behavior of it. But so if you sort your tree, then all of the modules will be sorted alphabetically. And let's say I want to look at a calculation tag to see what's available in it. I can scroll through my list here and find calculation. And as soon as I click that, the window down below gives me a list of all the variables and parameters available, or not necessarily available, but within that tag. So a calculation tag is essentially a collection of all these memory locations, which are variables and parameters. Okay, so that's one way to go into your tag, each tag, and see what you can use after the backslash to pull some of those values from the tag. So if you haven't written code, the source debugger can sound scary, but as you've seen, the steps are pretty simple to open it up, and you're using it as a very basic function of it just to see what's in that tag. So you could do the same. I'll just show you guys an analog status before I close it out. Okay, so the analog status is the same. You have your name, area, description, device, address, and your scaling parameters. So all of this gives you a way to see what you can access. Second way to see what you can access is use an Idea Studio. So I'm going to open up the Idea Studio. I'm just going to create a new page really quickly so I don't ruin my slides. Now for this one, you have to create a new widget, a tag widget, for the type of tag that you're interested in. So if I want to check out analog status, I can click on it here, click OK, and I'm going to just name this widget. Widget 1's fine for me for now. And I'm going to draw a square on the screen. It can be anything that has parameters, and you'll see why shortly here. If I bring up the properties of that square, instead of setting the color using a hard-coded value, I'm going to click on the little arrow here and select link tag property. Okay, so that's giving me access to the tag that's going to be drawn with this widget type. And once I do that, it presents me with a tree, and I get a list of all the parameters and variables within the tag. So this is a secondary way of determining what's available to you in any of these tags. And then if you switch it to expression, this is a quick way. It shows you what VTScada has done to turn that tree into an expression to refer back. So if you want to see how to write your own, sometimes you don't just want to pick something. Maybe you want to pick something and divide it by 10. You can pick it in the tree, like I did, and then you change your format to expression, and then we show you what the engine has done to write the code or the expression from you picking that in a tree. And then from here I could further modify this to, I'm sure I put a division sign in there. Divide by 10. Okay? Okay, so moving on a bit, we're back to the referencing, how to refer to tags inside your calculations. A really neat concept we have. I don't know what we use as a term, but I call it the dot dot. But when you're working with tags and you're trying to refer to different levels in the tags, you can really think of that as, I often equate it to your file system in your OS, in Windows. So in Windows you just have different folders, you have files inside folders, and you have this hierarchal means of navigating your files. In our tag browser, I kind of think of it the same way. So if you've ever used DOS and you're inside a certain directory, you open up your command prompt and you can type dot dot and hit enter. It's going to bring you a level up from where you're at. So we have the same notation in VTScada. And I don't know if we call it dot dot. I assume we do. But if you're writing a calculation, it allows you to specify or to control somewhat the level of the hierarchy that you're evaluating within your expression. So we'll see an example of that, 3.5. Okay, so here are my 5 calculations. So if you remember earlier, we had a calculation tag. So tank 1 level is the level that we're looking to evaluate, let's say. Just like we had earlier, we have 3 tank 1 levels kind of nested here. Now, tank 1 value earlier was immediately picking tank 1 level at its own hierarchy or order level in the hierarchy. Now, in this case, so tank 1 level is 3, But our tank 1 value is now displaying a 2, so it's referring to the tag above it in the hierarchy. So let's have a look and see what it's doing here. So it's using the dot dot to work its way up the tag tree. Instead of using the one at my level, I want to go up and use the one at that level. Okay, so it's the same demonstration with name. Okay, and now we have another different kind of reference here, absolute references. So what we were seeing before was relative reference. So if we had a tag that was looking at another tag and we deleted the original tag, it would work its way up the tree and eventually find something that matched that tag. At times, maybe you don't want that to happen. You maybe want to say, I want to refer to this tag, but if it's not around, I don't want this guy to do anything. I don't want you working your way all over the place and finding the first thing you see. I want you to display invalid or nothing at all. So to do that, you can use these less than and greater than signs within your reference to your square brackets to the tag name. And that'll force you to use the tag. So on the upside of the previous way we did it, where you just had the brackets, if you were referring to tank 1 level, if you changed its name, it couldn't find that tag anymore because it's looking for tag 1 level. Using this method, it's not referring to the name that we see, to the friendly name. It'll actually cause the expression to look at the unique name of the tag. So now you can move this tag around, you can rename it. Your expression is always going to refer to that tag, no matter where it lives. So we're on 3.6. Okay, so here I have tank 1 level. Its value is 1. And I have 2 separate calculations. Both of their values are 1 because they're referring back to the same tank. But in this case, we're using both referencing methods that I talked about. So this guy is using absolute. So I have my less than, greater than sign, full path of the tag. This guy is using relative, so it's only referring to tank 1 level like we've seen earlier. So if I was to open up the properties of tank 1 level, and let's say I change the name to tank 1 level B, you'll see that now one of my calculations continues to work, this guy here, because I've used absolute addressing. So it's not referring to the friendly name or the modifiable name, it's referring to every tag has a GUID, a unique ID onto it. And this calculation is actually referring to that GUID. This one's invalid because it can't find anything within its scope anymore. But if I was to add a second tag 1 in there, it would find that tag. Okay, you see it on the screen here, what's happening. And lastly, I think within tag referencing, yep, a little bit about hierarchical type references. You've probably seen this indirectly if you've configured a VTScada system where if you add an analog status tag or an IO tag of some sort, if it's a child of a driver tag, a Modbus driver, let's say, for example, that tag will automatically inherit the driver that's its parent. So it works its way up the tree. And similar to what I said before, where we had an actual tag name working its way up the tree for a tag name, there are certain types that you can use that for as well. So for instance, if you use star driver, star port, the tag will work its way up the tag tree until it finds a tag that is labeled as star driver or star port. So it's a way that you can refer to the closest port, driver, different types of tag within your hierarchy. Okay, so I have two tags here, two calcs. This one has star driver as its, I'll show you how it looks here. So, and I'm actually using the short name so we can display not the value of the driver, but the name of the driver. So it's using same square brackets, but instead of using the tag name, it's using star driver. And then this guy is using port, and you'll see that it's referring to the first tag in the tree. So even though it lives here, it works its way up to the tree. It finally finds COM1, which is a port tag, and it's going to display that as the name of the tag. So we do have a concept in VTScada. We touched upon it a lot during our scripting class, but there's a concept of invalid. If you've seen any other language, it kind of equates to null. So I like Keith's example of it when we were teaching together. Keith and I don't know if you guys have had the opportunity to meet Keith, but he said you think of a status tag, you would think of a binary. It could have a value of 0 or 1, but in VTScada it could have 3 values. You can have 0, 1, or null, meaning no real numeric value. It hasn't been assigned a value, and it's just in memory with no value assigned. It's invalid is what we call it. I shouldn't have said null, it's invalid. Now when you build an expression, so an example of invalid would be you have an analog tag and you get a COM failure. Its value is going to be invalid because you can't go out and read from the PLC. Unless you check hold on your driver, then it just retains the last one. If you don't have hold check, it'll go out, and when the driver fails, its value within the tag returns invalid. So if you're trying to use \value in a calculation, you're trying to add 100 to the value of a tag, and your driver fails, the value goes to invalid, and any expression with an invalid in it will return invalid because it doesn't know how to evaluate or how to deal with that value that doesn't really exist. So we return invalid for the entire expression. And it's really useful in a lot of what we do where there's a function called valid that'll let you know if something is valid or not. So at times we can use that as a condition to say, if this is valid, display the square. If it's not, let's say the pump. If this is valid, display the pump graphic. If it's not valid, don't display it. Maybe the tag doesn't exist. So you can use that as your condition, as an expression in conditions of widgets to turn things on or off. And the next really useful one is we have this function called pickValid. And in one sense, pickValid would allow you to default values if what you're really interested in is invalid at that time. So a pickValid allows you to have n parameters. So you can have one, shouldn't have said one, but parameter 1, comma, parameter 2, comma, parameter 3, as many as you want. And when pickValid is evaluated, it works its way through all of those, and it'll return the first valid one that it finds. So you could have something like pickValid tank 1 level, comma, 0. So if you're not reading a value from the tank, it'll default to returning 0 as the value. So let's say you had pickValid tank 1, comma, 0 plus 100. You'll always have a value for that expression, even if you're not reading the value from the tank. Okay, because the pickValid is going to default your tank 1. It's not defaulting it in the tag, just in your calculation, but it'll default the expression or the calculation to use 0 if the tank value is not valid. Okay, I didn't ask if there's questions because I do have a little demonstration on the next slide here. So, okay, so we're at 4.3. Okay, so here we have tank 1 level. We have tank 1 level defaulted. That's a calculation. So it's looking at, so it has this exact thing that I told you guys about. So it has a pickValid tank 1 level, comma, 0, and it's adding 1 to it. I realize the text is, but it's this expression I'm looking at is the exact same expression as the one in the example down below here. And then my second calculation tag, not defaulted, is just what we've seen so far, where you're referring to the tank level and you're adding 1 to it. So right now, everything's great. The tank level is 1. It does have a value, so I'm going to go in here and change that value. So instead of setting that, I'm going to delete my constant in there. I'm going to hit OK. The value of tank 1 is invalid, so there's nothing being displayed. So in that case, this simple expression gets an invalid value assigned to it as well. But the one with a pick valid around it actually retains the value that it has. Well, it decrements because tank 1 was a value of 1. Now this part of the expression is returning 0 and adding a 1 to it. Okay, so we're defaulting the value using this pick valid function. Okay, so moving into text. Text in expressions is delimited by quotation marks to tell the engine that this is text that I'm adding in the expression. So you'll see that this calculation here, quotation hello world produces hello world. If you want to display quotations in the result, so in your string, if you want to, we're using the quotes to say it's text, but what if you want quotes inside the string itself? Then you have to use a double set of quotations to tell the engine we're not trying to wrap the text with this, we want this to be in the string itself. So in that case, we have the quotation, the first one and the last one, which are delimiting my entire string, and then I have double sets around quotes, and you'll see that those actually show up in the result of that calculation. Okay, so string manipulation, real useful when you're creating some pages and widgets. You might want to build these strings up that actually speak a little bit to the operators to say the value of this is occurring now, and you could, build some more verbose kind of indications for your operators. So to do that, a real good function to know is concat. And concat can take, when I say n, it's not a fixed number. You have to have at least 2 parameters. But you have as many parameters as you want, and it takes each one of those and builds a big string out of them. But it has a similar result to any other function, and if I'm trying to concat, so in this case I'm trying to say tank 1 level description. If I haven't set the description of tank 1 level, this portion is invalid, and that forces the entire concat to be invalid. Okay, I don't have that in my slide, but I'm just thinking of it looking at it now. So I could wrap each portion of these into a pick valid to say, so in this case, I could have pick valid tank 1 level description, comma, unknown. And then when you build that string, it would say unknown has a value of, 15 or whatnot. Okay, so you can use the pick valid on each one of these portions of the expression to ensure that you always have a valid string coming out. So the result of this is that we have tank 1 has a value of 15 feet. You could use that in, so if you drew text on your page, instead of typing the text in, you can select expression and put that expression in the text, and you would get the value of the tank in a more verbose fashion. Oh, I actually did have pick valid in there. I thought I was being smart. Application properties. Not going to go too deep into them, but you can create your own application properties, and I did that in this case. So I have this thing called demo property. And the application properties are things that you may have seen where it lets you adjust. Do you have auto deploy turned on? What's the resolution of my screens? All of these things that you configure from, I should stop talking and bring it up to show you. Expressions here. So from the edit properties here, these are all of the properties that you can access. You only get a set few in basic mode, but if you go into advanced, you get a big list of everything that's available. And you can easily add your own in here through this interface. I created one called demo property. And I'm just going to search for it. So here's my demo property. And the value of it is this is a demo property. So my calculation, I'll bring this up just to show you. I'm in section reference 6. So to refer back to that application property, you simply prefix it with a backslash, and then you type the property name in here. So this is a calculation that's just referring to demo property. So in that case, if I was to modify that value, I can change this from this text string to 45. And now, oh, and I hit apply, sorry. Yeah. Now the expression is referring to 45. So if you want to create these global variables for yourself, your expression can refer back to those variables, and you can change them on the fly, and your expressions will reevaluate to refer back to the new value. What's the value, and what is the type that it assumes? It's dynamic typing. All of our variables are. So if you type a number in, it'll assume it's text, and it depends how it's trying to use it. If you type 45 in, it'll draw it as text and let you trend it. If your expression is concat site1 plus demo value, it'll concat that 45 as text onto the text string and build a text string out of it. So it's very powerful with its typing and dynamic and determining what type it should use. So we do have a lot of functions. You've seen the now, you've seen concat, you've seen pick valid. It would be worthwhile looking at some of these every once in a while because there may be things that would simplify your life. And we do have it sorted by, I can't copy because it's not. So if you search the help file for VTScada functions, there's VTScada functions and statements. Oh, shoot. Function reference is what I was looking for. So this breaks down all of our functions into given types. Now, not all of these are going to work with calculations. Some of them are meant to be run on arrays, which you're not going to usually run into with calculations. You'd be writing script code, but excuse me, all of our functions are documented in here with examples and descriptions on how to use them and what the parameters should be. So here's where we come into this steady state versus script. Everything we've seen so far, we call it, we tend to refer to it as running in steady state, meaning we don't have something triggering it to say, okay, this happened, calculate that. Rather, the calculation is always running, and if something that it's trying to look at changes, it reevaluates automatically. So those are called steady state. So to determine if you can use a function in our calculation or not, inside the help file, we tell you if it says steady state or not. So every function will have this usage section, and it'll say steady state only. So in this case, you can use this in a calculation, and you can only use it in a calculation. So this 1 seconds is script only. So if I try to use that in a calculation, the engine will throw an error saying you can't. Okay, so you cannot use functions that say script only. Okay, I want to touch on time real quick. I added this slide in to try and make it a little bit different than last year. If anyone's been here, I recognize some faces, so you probably remember some of my slides. But bringing in time. So if you're using any timestamps in VTScada, at the low level, we track time using epoch time, which is the number of seconds since January 1st, 1970. So that's what our timestamps are based on. That's the format that we base it on. So as a reference, January 16th, 2019 at noon is this number. So that refers to this time. So working with timestamps, from time to time, we do have some function calls like date and time. Their input is not the full timestamp. What they're looking for is the number of seconds since midnight or the number of days since January 1st, 1970. So the epoch time is the number of seconds since January 1st, 1970, but oddly enough, we have a few functions that are looking for a number of days or a number of seconds since midnight. So if you do have a timestamp, like this one that represents January 16th, I think it's today, I tried to make it the day. If you do a remainder operation on it by 86,400, and what 86,400 is the number of seconds in a day, right? So it's 60 times 60 times 24 is 86,400. So this expression, so by doing the remainder 86,400 on a timestamp, will return the number of seconds since midnight. if you want to get the number of days since January 1st, 1970, you can use the int. So in this case, you're dividing instead of doing the remainder, the same numbers, but you're placing an int in front of it. So you're only getting the full version of the number. You're not getting anything after the decimal place. So this gives you the number of days since 1970 for this timestamp. Okay, so working with those in a string format, call this creating a clock. But we do have this time function. And with time, if you pass in the number of seconds since midnight, you can specify a format that you want, and it will build a time string for you. So I'm going to show you all the different, not all, but just quickly. So you have full control over how the clock is displayed in time using the time function. So here's some canned formats. So 3 displays hour, minute, second, and hundredths. 4 is this, colon, this, colon, this. So there's some canned ones, but you can also build your own just using capital H is hours with no leading 0, for example. So that's kind of what I did. Well, it's exactly what I did here. So I have 2 capital H's, which is 24-hour format. And I would get a leading 0 in front of it. So if you're trying to line things up, if you only have 1 hour, you're not kind of skewing over to the left. Okay, so similarly, there's a function called toDate that will return a date string based on a numeric timestamp value. So in this case, we're getting the day of today, the date of today. And then you could simply concat both of those. These are just the tags that are running these calcs. You can concat them together and build a clock. Okay, some functions need to be reset. So if you just run timeout in a calculation, timeout returns true after a certain amount of time elapses. But in a calculation, there's no way to reset it. So once the 5 seconds elapse, its value returns 1 and it stays 1. The only way to reset it would be to disable the tag, and I'll do it in this case, and we'll see this guy switch. So I'm in section 9.1. That would be... Okay, so I'm going to disable this tag and bring it back immediately. And I want to be able to show you guys what's happening here. Okay, so it's 0 for 5 seconds, and then it should switch to a 1. But now it stays 1 permanently, so some of these functions need to be reset, and we do have a mechanism to do that. A little bit complicated, but I got to show you guys that it does exist. So we have a latch function, and the latch is essentially wrapping functions that have to be reset within it. So latch has 2 parameters. I kind of think of it as the on and off. So whenever the first parameter becomes true, latch will return 1. And then when the second parameter becomes true, latch returns 0. So, but anytime it returns, it'll reset whatever you've put into the first parameter. So in this case, we're still using timeout. But because we're wrapping up in the latch has a reset function that's allowing us to use those and switch between them. So in this case, root value is the value of the calculation tag we're looking at. And timeout has, the first parameter is should I run or not. The second parameter is the number of seconds. So what it's doing, I'm going to, just give me a second here. I'll make this a little bit more legible. It's very clear for me because I've seen these things many times. Might help a little bit. So when this calculation starts up, I'm saying if my tag value is false, wait 5 seconds and set my timeout. So when it first starts up, my expression, my value is false. In 5 seconds, it turns to true. As soon as this becomes true, this second timeout is saying when my value is true, so if the value of the tag is true, wait 2 seconds and start running the timeout. So then this timeout begins, and when this timeout elapses, you're setting the second parameter, which sets the value back to a 0. So it's a way to toggle between the two parameters in here. And you'll notice that the number is actually going to a 1 after 5 seconds, and then within 2 seconds it goes back to a 0. So it's a way that you can reset your functions within a calc. A really useful thing in calculations, any sort of scripting or coding, is an if-else. So what it allows you to do is say, if this is true, return this. If it's not true, return the next value. So we do have that in our calculations as well. So we have an if-else, the pump 1 status. So pump 1 status reads true if the pump is running. So if the pump's running, display pump is running, else display pump is stopped. And we have a shorthanded version, which is simply a question mark colon. So instead of using this if-else as a function, you can simply set your condition first, question mark, your return if it's true, colon, return if it's false. And I'm skipping over this quick because I'll show you guys some more examples of it later on. Not too much later. Was there a question? Oh, I thought I heard something. Okay. They can be nested as well. So if tank is less than 10, you return tank 1 is low. If tank is greater than or equals to 10 and it's less than 90, tank 1 is normal, else tank 1 is high. So you can have if-else nested within each other as well. So in this case, I can play with this guy. I can set the value to 50. Tank 1 is normal. And if I set the value down to 0, tank 1 is low. So you can nest them and do some really neat stuff. Operator input. So you can create operator input calls and refer back to those in your functions as well. There's a special way to use our analog control tag. If you don't assign an I/O device to an analog control tag, you can draw it with widgets, with control widgets, and if you type a number in, it's going to set the value of analog control. It's going to synchronize the value of it across all your machines that are running that application, and it also remember that value across restarts, so it retains the value as well. So it's a really nice way to use set points. It's almost a memory tag within VTScada. So this here is, and you have access to all the widgets, so you could use slider bars, you can use any of the controls that we have for analogs, you could use for operators to set the value of that memory tag, if you want to call it that. So this edit field is referring to my tank volume. And you see that the value of my calculation is my tank level in percent, divided by 100, multiplied by my tank volume. Tank total volume gives me the current volume of liquid in the tank. So I could change that from, right now I'm saying that 50 is the total volume of my tank. I could change that to 100, meaning my tank is now a 100 cube or 100 liter tank. And I'm at about 50%, and I'm displaying about 50 cubes, 50 units of volume, whatever that might be. Okay, in widgets, here's a really 5 levels of nesting. We talked about that. So we're saying if our station tag value is 0, you display pump stopped. And this is a way to build an enumerated list. So if the value is 1, display pump running. If it's 2, pump tripped. And I have a value of this calculation that's just cycling up through all the different values. And you can see, as it's doing that, the value of this expression is changing to display the actual value in the enumeration. There's a neat little color palette in here, so you can see what the numbers are. The new ways of doing colors are more complicated. There's like a text string of 6 numerics. Yeah?
Can you do that last group you had, could you tie that into specific bits on a register?
Yeah. So if you want to get a bit on a register, didn't mean to do this. It's not that complicated. So the easiest way to refer to a bit, so let's say you're reading a register back in an analog. There's a bit function in VTScada. And you pass it value and bit number. I'm just going to bring this up in an editor so you guys can see it here. Format, word wrap, font, So true is a function that returns 1 if what it's evaluating is true. It returns 0 if what you're evaluating is not. So this bit function allows you to specify a value, and you can specify the bit number you're interested in, and it returns true. It will give you the value of that bit number. So then we're passing that value, that bit number, into the true statement, which will return true or false based on if it's true. So in this case, we're saying the first bit is set. New keyboard. Okay, so this example is saying if the first bit, bit 0 is set, the texturing would be error 1. If the second bit is set, it's error 2. Otherwise, error 3.
What was the exact question again?
Oh, we wanted to, so in this case, we're looking at a value that we're reading, and we're saying if the value is 1, 2, 3, a lot of these devices have a bit mask. So you're reading a register of 16 bits, and based on bits being set, you can determine certain conditions of the device. So we wanted to know how to refer into those specific bits. Yeah?
So what if you had 2 of those bits were true? Which one would take precedence?
So it starts at the beginning. It starts at the top and works its way through. So if the first one's true, it returns a condition for true and it stops evaluating. Okay. Yeah. Okay, again, shorthand. We just drew a rectangle, and based on if the seconds are odd or even, we're just picking a different color, 103 or 79. Workstation. So I told you everything had to run in steady state. We can build an exception to run the script-only functions that you want to run in VTScada as well. This is a really neat thing. So usually if you run calculations, a calculation tag, a screen, anything you're running, every instance of that is running independently on each workstation. So each workstation is making its own calculation. So if your clock is wrong on one, the values are not going to match across all your workstations because they're looking at their own clock when they're running that calculation. What the workstation driver allows you to do, in its basic format, it's just a driver. You can set analog tags up to it. You can see the number of the disk size left. You can see your CPU usage, your memory usage. They've enhanced it so that you can run calculations, but the power of it is that the calculations are only run on the machine that you specify. And then they're synchronized, so that machine evaluates the calculation and synchronizes the value across all the others. So as I'm showing you the version here, we have a company called Hierarchal out in Calgary. They're one of the biggest oil producing companies globally, I believe. And they have a lot of SCADA systems. They have a lot of servers. So I built the SCADA app, which is a workstation monitoring app. And for every one of the computers, they monitor CPU cycles, they monitor memory, they trace all that stuff. So they can go back and see if their CPU usage is hiking, if their memory. So it's essentially a dashboard or a SCADA system for their servers. But what they like to do is they're running oil and gas layers, driver packs, all these different versions. They want to bring up this page and see where their the versions of software for all their different servers to know if they're up to date or not. So, long story short, you can use this workstation driver so that the version is evaluated on that workstation. And when you're looking at it on a different workstation, you're seeing the value that's calculated on the one that you specify. You're not seeing your own version of software, you're seeing his. Where if you tried to do this with a calculation tag, everybody would be calculating their own version, and you wouldn't know what that workstation version is, you know your own. Okay, so you have to, it's a driver. When you configure the driver, you say it's going to run on this workstation. And when you configure an analog, the address of the analog will be expression, colon, and the calculation to run. And now the scan rate's important. If you remember, the scan rate on an analog usually says how often do you poll. In this case, it's going to say how often do you reevaluate the calculation. Okay? Now these calculations have to be script in this case. So when you're in the help file and it says steady state only or script, if you're using these workstation types, they have to be script. Okay, I'll touch on this real quick. I'm running late, and it's snapshot expressions. Now, I would have covered this under my other seminar. Typically, this stuff is reserved for tag types. So it allows you to set the values of parameters of child tags. So in the case of you might have a site with 3 pumps, and maybe you want to use it for duplex or triplex pumping stations. So you'd add a parameter to your site to say, how many pumps do I have? And then each pump would only start if the value is, so pump 3 would only start if the number of pumps is 3 or greater. Okay? So these snapshot expressions allow you to set the value of parameters within the tag. 5? Okay, again, some of this stuff I'm going to skip because it's more tag type things that we would have covered. This topic will be expanded further in the seminar that I did yesterday. Again, a nice thing you can do is use expressions to play with the opacity of graphics as well. So in this case, I'm in example reference 15. So in 15, I just so happen to have one of these sites. And you'll see that I have 2 pumps. 2 pumps. If I click on site and bring up the properties, there is a property that says has pump 3. So I set this true if it has the 3rd pump. So I click on 1 here, and OK. And now I have the 3rd pump in my site. And I have the 3rd pump drawn on my screen as well. So we used to really struggle with this stuff. If we wanted to create a template, and especially if you had buttons and controls, you want to control pump 3, but if it's a 2-pump site, you don't want to build another page, but you don't want to let people press that button and you don't want it on the page if it doesn't exist. So our old method was to use calculations in coordinates. So if it didn't exist, you'd change the coordinates to negative something and move it off a screen. That's all right, but it gets really tough when you're trying to edit a page and stuff's all over the place, and it gets really, really messy. So here I have a widget for that site, and I'm going to open it up to edit it. And I have the same widget being drawn 3 times for each of the pumps. And on the properties of this widget, there is an opacity setting. Oh, see, I wrote this as an expression, and the engine said, oh, I'm more clever than you. You don't have to write an expression to do that. So I'll do it the GUI way. Before I clicked OK, and you know what it's like? It's like taking French and putting it into Google Translate and then translating it back to English. You don't get what you started with. Same result in this case, but I actually typed this in. And it tried to be a little bit smarter and add all kind of defaults and stuff is what it did. Actually, it was less than that. So you can use a backslash in the widgets to refer back to the parent properties. And with this opacity, either set it to a 0 or anything in between 0 and 1. And like 0.5 would be half opaque, so you could somewhat see through it. But if you set it to 0, it's a special case so that it doesn't even draw it. It's not just that it's invisible, it's not on the screen, so it doesn't interfere. If someone clicks on it, it doesn't open up an empty trend or things like that. No, scale used to be, because opacity used to make it invisible, but you could still click on it and activate it. So we used to use scale to move it off the screen so people couldn't. But opacity's been enhanced. So in new versions for the last 2 or 3 years now, if you set opacity to 0, it doesn't function at all. I'm almost done, Natasha. Okay, things to be careful of, and this is the last slide. A big one is circular references. So I said that VTScada will calculate something when something in the expression changes. In this case, tag 1 is being set to the value of tag 2 divided by 100. Tag 2 is tag 1 plus 50. So in this case, this will evaluate. And because tag 2 is looking at tag 1, it now evaluates, which changes the one in this expression to evaluate. So this is just going to cause you 100% CPU. It's trying to calculate these things as fast as they can. A lot of people will build these things and assume start order. So you see calculations, and some people will build these extremely large, complex webs of calculations and things to refer to. When things start getting too complicated, it's worthwhile taking a script course. It's a couple of days. You can ask these guys. It can get pretty hairy, but you can also do a lot with a small little bit of scripting knowledge. And if you were to build yourself a module, you can actually open up the source debugger and see what's happening with this stuff. When you're building calculation tags that refer to each other and you have these big long strings, it can be really hard to know what piece of my expression is broken. Like it's invalid. Maybe in a case it's invalid. I don't know what part is invalid, causing everything to be returned that way. So just be careful it doesn't get out of hand complexity-wise. And then even worse than that is I've seen people build these really complicated things that automate their systems. So they're using the result of these calculations to turn pumps on and off, which is even scarier in a way, right? When you write code, you can guarantee the order of certain things happening if you write it properly. With expressions, you don't know which tag's going to start first, and maybe this starts up and this doesn't have a value yet, and you have to accommodate for all of those unknowns. So just be careful with some of this stuff. And that's it. Thank you, guys.